Okay, today we're going to look at our last topic for solving quadratic equations. So we did graphing, which worked for any equation. We solved that algebraically if it was in vertex form. We looked at solving in standard form using factoring, but when we get into harder questions that don't factor very well, we need a new method. And the last one then is using the quadratic formula. So the quadratic formula is this here, and it's on your formula sheet, and basically it just refers to our standard equation. So the A, B, C's in the formula are just the numbers that we get in our standard equation. So it's pretty simple. You just plug the numbers in and solve it mathematically. So let's try for our first one. So like, remember, if we tried to do this one by factoring, it's a little bit difficult. So we'd have to go 3x and 1x, and we'd have 21 would give us 7 and 3. We need one of them to be plus and one of them to be minus. So then we'd have to guess and check to see if it actually worked. So we have 3x squared minus 9x plus 7x. So these are indeed the factors. So our solutions then would end up being minus 7/3 and positive 3. So it does work by factoring, but let's actually try this one now using our formula. So our formula is minus b plus or minus b squared minus 4ac all over 2a. So if we plug all of our numbers in, minus b would be 2, negative and negative 2 would be positive 2. B squared will be 4, and then we get minus 4 times 3 times negative 21. And all of that divided by 2 times a, which would be 6. So if we actually simplify all this, 4 times 3 times 21 gives us 256 under the square root all over 6. But the square root of 256 is actually 16, so we get 2 plus or minus 16 over 6. So the plus or minus just means we get two different solutions. So we'd have 2 plus 16, which is 18, over 6 would be one solution. And then we'd have 2 minus 16, which is negative 14, over 6 for the other solution. And if we simplify those, 18 divided by 6 is our 3. 14 over 6 would give us our 7/3. So we can get the exact same answers just by using the formula and simplifying it instead of trying to do some of the harder factoring. So here's another one. Let's try this one. So we have 3x and 1x again. Our 7 has to be 7 and 1. So let's guess this way, and we want plus 4. So let's try plus 7 minus 1 and see if that works. So if we FOIL these out, we get our 3x squared, we get 7x, we get minus 3x, and minus 7. So this one does work. We actually would get our right answer. So from there, our factor should be negative 7/3, and positive 1 would give us our solutions. So that works well for that, but once again, we could use our formula. So minus b, so let's try it. So we have negative 4 plus or minus b squared, which would be 16, minus 4 times 3 times negative 7. All over 2 times 3 is 6. So if we simplify that, 4 times 3 times 7 is 84, so the two negatives cancel. So 16 plus 84 is 100. So we'd get minus 4 plus 10 over 6, and minus 4 minus 10 over 6. So that gives us 6 over 6, which is 1, and the second one would be minus 16 over 6. Or minus 14 over 6, which would give us the negative 7/3. So we do match the answers once again. So it's totally up to you. If you would like to factor and it works, great. If you don't and you have trouble with those ones, then you might want to choose to stick with the formula. Okay, here's another type, and these can be a little bit difficult. So you look at it, they look pretty confusing. So you actually have two different options. You can FOIL out the brackets. So we could actually do the x plus 3 times x plus 3 part first. So that gives us x squared plus 6x plus 9. And then we want to times that by 2, and then we just FOIL out the rest as well. So in this case, we'd have 2x squared plus 12x plus 18, and then minus 11x plus minus 33 plus 15. And if we simplify all that, we get 2x squared, 12x minus 11x would be 1x. 18 plus 15 is 33, minus 33 would give us 0. And in this case, it's probably easier just to do common factoring. If we just take out an x, we'd have 2x plus 1. And that's it. So our 2x plus 1 would give us a solution of negative a half, just like we did before. And this x in front is just x equals 0. If there's an x by itself, the 0 is 0. So that's it. That's how we could actually do that one. The other option is we can see that the brackets are the same value. So we could actually just change that to a different letter. So let's just use a. So if we go 2a squared minus 11a plus 15, now it looks like a regular quadratic, so we could actually factor it. So we'd have 2a and 1a. And we want 15, so we need 1 and, well, 1 and 5 work. 1 and 15. Maybe it won't work. 5. If we do 5 and 3, that would give us, 5 and 3 will work. If we do 5 here and 3 there, I think it works. And they both need to be negative. So let's just double check. 2a squared is good. We get minus 5a and then minus 6a, which would give us 11. Yeah, so that's good. So anyway, we end up getting our two solutions would be 5 halves and 3. Well, those answers don't look the same, but remember, we said a was equal to x plus 3. So we actually have to put those numbers back in. So 5 halves equals x plus 3 would be one solution, and the other one would be 3 equals x plus 3. So if we bring the 3 over, we get 0. So there's our 0. And if we bring the 3 over on the other one, 5 halves minus 3, 3 would be 6 halves. So 5 halves minus 6 halves would be negative 1 half. So that matches our two answers doing it the other way. So it's totally up to you. FOIL it out and simplify and then just solve it normally. Or you could try a little shortcut by factoring and then just plug in your values afterwards. Okay, here's another one. Let's do this one by foiling out. So we'd have x squared minus 8x plus 16. Then we get 16 minus 4x. So if we simplify all that, we would get minus 12x. We'd have 32 minus 21 would be 12. Is that right? 16 minus 21 would be 5. Oops, it would be 11. Sorry. So minus 11. So now our factors would be x minus 11 and x minus 1, which doesn't seem to work. Let's see, we need to get, let's just double check our math. X squared minus 8x plus 16 is right. 16 minus 4x is right, minus 21. So 16 plus 16 is 32. 32 minus 21 would be plus 11. There we go, that works better. So we'd have minus 11 and minus 1 would be our two factors to give us plus 11. They do add up to negative 12. So our solutions would be 11 and 1. Okay, so you can factor if you still want to, or, like I said, if you get to harder ones, then that's where our quadratic formula will come into play. So when you get to questions that don't factor, like if we look at this one, if we try to factor 3 into 1 and 3, we need them to be negative, so one would have to be negative, one would be plus, but they're never going to add up to negative 1. So that means that method, factoring method, won't work for this case. So then our option is what could we do? So let's go to our formula. That'll be our only choice in this case. So if we go negative b, so that would be 1 plus or minus square root of b squared, which is 1 still, minus 4 times 1 times negative 3 would give us plus 12 over 2a, which is 2. And if we simplify that, we get 1 plus root 13 over 2. And you can just leave your answer in that form. You don't need to do anything else, because our two answers would be 1 plus root 13 divided by 2. That would give us a decimal answer. And the other one would be 1 minus root 13 over 2. And that would give us our other decimal answer. So if you do the quadratic formula like this and you're not sure you got it right, a good idea would be just plug it in by graphing, and you can actually verify that those decimals do indeed match. Okay, here's another one. So let's use quadratic formula again. So we'd have minus b, so that would be 9 plus or minus b squared, which is 81. Minus 4 times 2 is 8. Times 5 would be plus 40. All over 2 times 2, which is 4. So in this case, we get 9 plus or minus root 121 over 4. Root 121 is actually just 11. So we'd have 9 plus 11 over 4, which would be 18 over 4, or sorry, 20 over 4, which would give us just 5 as one answer. And then we'd have 9 minus 11 over 4, which would be negative 2 over 4, which would be negative a half as the other answer. So this one's actually the answers are pretty good. So we could have factored this one. If we would have wanted to, we could have went factor of 2x and 1x. We could have went 5 and 1. And we would have had plus 1 and minus 5 would work. And then those would give us those exact same answers. So it's totally up to you whether you want to factor or use the formula. Okay, here's another one. If we actually use our quadratic formula, we'd get 6 plus or minus b squared is 36. 4 times 1 times 9 is 36 again, over 2. So you can see when we simplify this one, we get square root of 0. Square root of 0 is 0, so we just basically get 6 over 2, which would be 3. So what that means is we actually only get one solution. So if we look at this in terms of factoring, we'd have x minus 3 and x minus 3. You can see that both factors are the same. That's why we get only one solution. So in terms of our graph, we'd have just one solution at 3. So you can see we can actually figure that out from the quadratic formula, and the reason for it working that way was we have a square root of 0. So that square root of 0 means that we only get one solution. If we go back to the last example, we had a square root of 121, which was 11. That gave us two solutions. So let's do one more. If we do the quadratic formula on this one, we'd have minus 6 plus or minus 36. Minus 4 times 1 times 12 would be 48. We divide it by 2, so you can see in this case we get 36 minus 48 is negative 12. And we can't do the square root of negative 12. That doesn't exist. So that means there are no solutions. So what does that mean? If we actually look at the graph on this case, this would be a graph where it doesn't have any x-intercepts. So you can see we actually get three different scenarios. The first example had a square root of 121. That gave us two answers. This last page we had a square root of 0, which only gave us one answer. And if we had a square root of a negative number, that meant we had no answers. So that square root part, it actually tells us quite a bit, and we call that square root part the discriminant. So we can actually figure out how many solutions are going to be just by doing that square root section. And like we just looked at, if the square root is 0, that means we only have one solution. So if you have square root of 0, you're just going to get one. If our square root is positive, that's when we got two solutions. And if we get a negative under the square root, that meant we get 0 because we can't do the negative square root. And that's it. So we're done with solving equations. So the quadratic formula works well for any standard form. It doesn't matter how easy or how hard. It'll work. It'll give you the exact answer, especially when we get answers like 6 plus or minus root 3 over 2 or something like that. So it'll give you the exact square roots. And the only problem is sometimes if you want to use it, you might have to get it into standard form, and it's a little bit of work in simplifying, but it does indeed work out. So if we actually did an equation in standard form and we got an answer like that, or if we converted it to vertex form, we would get the same thing. So you actually get the two formulas would give you the exact same answer in whichever form you would get. You might have to do a little bit of simplifying and rearranging, but they will be indeed the same answer. And that's all for the quadratic formula.